Right. Good morning, good afternoon, good evening, depending on the time you're seeing this lecture. This is the second video. The first one, I already sent it out, and I have a note to this too. If you don't have any of these two, you try to reach out to your class rep. I've already given it out. So, like I promised, I will be solving like 5 questions out of this example question. We have about 3 of them, and the example question is up to 14 questions. So, I will be solving 5 most important ones to actually give us an idea on how to go about it. My name is Adebayo Timileyin, and I'm also part of people taking PHY 102. So, the first problem on the item is calculate the resistance of a coil of inductance 0.32 Henry when it is connected to a 50 hertz supply. That's the first question. The second question is a coil has a reactance of 124 ohms in a circuit with a supply of frequency 5 kilohertz. Determine the inductance of the coil. So we'll be going through the first question, which is very mandatory. Like I said, I won't solve all the question, but I will try as much as possible to solve the most important one. In your free time, try and solve them also. So I'm creating a note so I can just use it to write so that you guys can see. I'll be changing the color of my probably to white. So that's okay. I think it's already there. Alright, so remember in our formula to calculate inductance of an inductor, the reactance of an inductor. The reactance of an inductor is given to us as XL, which is equals to 2 pi L, or rather, let's just follow the way it is, 2 pi F L. So, and the unit is in ohms, okay? So basically from the first question we have is pretty much straightforward. So we already have given the inductance of 0.2 Henry. Then we have the frequency of our supply as 50, which is all we pretty much need. So if we're going to look at this, F is equals to what? 50 hertz. Then L is equals to what? 0.32 Henry. Alright, so if we're going to calculate this, basically XL will be 2 pi times 50 hertz times 0.32 Henry. So if we use our calculator, we'll take our pi as we'll just take our pi as 3.142. Okay, so if we do that and we use our calculator, sorry about that. So we'll say that will be 2 multiplied by 3.142 multiplied by 50 multiplied by 0.32. So with that, we'll be having like 100.544 ohms, but we'll just, let's just write 100.5. Okay, let's write the entire digit as ohms. We'll approximate this to 100.5 ohms, which is our final answer. So let's consider another question on the item. Okay, another question that we think should interest us is problem number 4. Okay, if we look at problem number 4, there is nothing too much to it. It's just like a closely similar question, but we are looking at the capacitance. So the problem number 4, if we're going to read it together, problem number 4 says a capacitor has a reactance of 40 ohms when operated on a 50 hertz power supply. Okay, determine the value of its capacitance. This is pretty much straightforward, but the most important thing is we need to be conversant with our formula. So if we're going to calculate the reactance of a capacitor, is given to us by, okay, let me just minimize my space consumption. So we say xc is equals to 1 all over 2 pi. If you remember in our previous note, I already give this out. So our frequency in this discussion is what? Our frequency is 50 hertz, and we're given the reactance of the capacitor as 40 ohms. Okay, so that is not going to be much of a problem. All right, so F is 50 hertz and our XC is what? 40 ohms. All right, so we make C the subject of our formula. So C basically will be 1 all over 2 pi fxc, which is 1 all over 2 pi times 50 hertz times 40 ohms. Okay, so we'll be needing more space. So this will be C is equals to we can basically do this. This is 4 times 5, that's 20. So we can say this will be 2 pi times 200. Okay, so we can use our calculator to finish this off. So let's go to the calculator. So let's clean this. So this will be 2 times 3.142 times, let's just go to the 50 times 40. Okay, all right, but remember we have the inverse, so we'll take the inverse. If we go to our history, we'll take this. Okay, so sorry about that. It's equals to this, so we need to find the inverse. I don't know why my calculator is doing this. Okay, let's just do this, then go to our history and pick this up. Okay, this is better. So we'll see that we have 6.33. If we approximate, that will be times 10 raised to the power minus 9. I'm not really sure if this is correct, but okay, let's okay, so I think something is wrong with the way I punched the calculator. So this is actually correct. I think I punched the calculator wrongly. So this is 0.000079. So we'll find a way to represent this in a standard form. This will be 79.5 times 10 raised to the power what? We'll just bring our points 1, 2, 3, 4, 5, 6. All right, so that will be 79.5 times 10 raised to the power 6. Okay, 79.5 times 10 raised to the power minus 6. All right, that will be in farad, but if we take it to microfarad, that will be 79.5 microfarad. Okay, So let's look at, remember I said we're solving just or five questions. So we'll look at probably maybe another question, but not from this slide because we have more other, okay, this is another one. So in this other one, that deals with, basically, let's look at problem 6. Problem 6 is quite interesting because it's talking about the resistor inductor series AC circuits, which is one of the area I explained to us in the last slide. Okay, so problem number 6 is saying in a series RL circuit, the PD, we know PD is potential difference. The PD across the resistance R is 12 volts, and the PD across the inductance L is 5 volts. Find the supply voltage and the phase angle between the current and voltage. It's a pretty much simple questions. If you remember most of the formula we've discussed. So if I'm going to approach this problem basically, so I'm going to try and recall what the applied voltage or supply voltage will be. The supply voltage is given as the Pythagoras of the VL square, sorry, I mean to write VL square plus the VR, that's the potential across the resistor and the potential across the inductor. We find the power of them, then the square root of both of them after adding them up. This will give us the supply voltage we're looking for. And the second question also, if you remember, says find the voltage, find the phase angle. So the phase angle, the formula for the phase angle basically is VL, sorry, that will be the tangent inverse of the tan VL over what? VR. Okay, so these are pretty much straightforward questions. So we'll say 12 square plus yes, if let me just be sure what we're given. So yeah, that's 12 for the voltage drop across the resistance and the 5 volts for voltage drop across the inductor, sorry, resistor and inductor. All right, so that will be plus 5. Okay, I think I might have mixed it up. So this is for voltage drop across the resistor and this is the voltage drop across the inductor. Okay, so this will be if we do this, this will basically be 12 square. I know 12 square, but I don't want to rush into solution. I want us to be able to follow through. So we find 12 square, which is this 144. Then we also find 25, sorry, sorry, we also find 5 square, which is that. So on our board we'll say 144 plus what? 25. Okay, so which will give us we'll say 144 plus 25, sorry, plus 25. Okay, so that's 169. So square root of 169 is what? That's 13. All right, so this will give us square root of 169, which is what? 13 voltage. Okay, sorry, let's just rewrite this. 13 volts. Okay, all right, so this, don't forget, we have this here, we have this. Okay, so we're going to bring it out. We'll say the phase angle, which is the second part of the question, which is equals to tan inverse VL all over what? VR. So our inverse is what? That will be 5. Our VL is 5 volts all over 12. Okay, so if we use our calculator with this, we find 5 divided by 12. Okay, then we'll find the inverse. So to find the inverse on my calculator, I think this second function that will be than our previous answer. This is equals to 22.62 degrees. If we approximate that, that will be 22.62 degree. Okay, so we solve question number 6. So that means we've solved 3 questions. I promise us we're going to use this time to solve 5 questions. So let's look for more other interesting questions to tackle. All right. 3 questions out. We can take 2 more questions to add to it. Let's look at problem number 7, and then we look at problem number 13. Okay, so we by doing 7 and 13 we should round up. I'm trying to restrict this lecture within 20 minutes. I pray we have enough time. So this question number 7 says a coil has a resistance of 4 ohms and an inductance of 9.55 millihenry. Calculate number 1 the reactance, B impedance, and the current taken from 240 volts and a 50 amps, I think, power supply. Yes. Determine also the phase angle between the supply voltage and current. Quite a very interesting question. So let's quickly solve it. All right. So the first question is, let me just write clearly. This will be inductance. That's the first question. Inductive reactance, which is XL. Okay, our XL is giving us 2 pi FL. Okay, so that will be 2 pi. If you remember our question, we're given frequency to be what? 50 hertz, and then inductance to be what? 9.55 milli. Milli is that's 10 raised to the power minus 3 Henry. Okay, so we quickly, because we're trying to keep under our time, we use our calculator. That will be 2 times 3.142, okay, times 50 times 9.55. Okay, we'll keep our power of 3 minus 3 aside, so we'll say times 1, where is exponential, 1 times we'll just say 10 raised to the power minus 3. Okay, all right, that will give us 3.00061 ohms. Let's just ignore the 0 and say, so this is the first one. So the second one, which is B, and if you remember the question of B, the B wants us to find the impedance, which is Z. Okay, so if we want to find the impedance for the circuit described, the impedance basically will be Z is equals to square root of R square plus XL square. R square will be the resistance of the resistor, and XL will be the reactance of the inductor. Okay, so we just calculated XL now, and then we already been given 4 ohms as the, if you look at the question, we'll be given 4 ohms as the resistance of the resistor. So this will be 4 square plus 3 square. Okay, if we do this, this will be 16 plus 9 and square, that was 25. Square root of 25, which is equal to what? 5 ohms. Okay, so that takes care of B. And then C, Sorry, I'm not sure we'll be able to handle the last question, but the last question we're interested in will have been problem 13. But let's quickly calculate. See, the current will be V over what? Z, which is 240 divided by 5, which is equal to what? I think that will be 48 amps. All right, this is where we stop for this class. I admonish you to try and look at question number 13 at your free time. It's going to be one of our interest area. Try to study your notes. I'll see you around, and I wish you success in your exam. My name is Adebal Timilein, and thank you for listening to this lecture. Bye bye.